You know, have you ever tried to give someone really complicated directions? You find yourself automatically breaking it down, right? You point out landmarks, maybe you even guess where they might get turned around. It's this deeply human cognitive thing we do. But what would it take to get an AI to think and navigate the world in that same way? Well, that is the huge puzzle that a new AI framework called FindCogNav is trying to solve by basically mimicking the structure of human thought itself. So let's dive in and see how they pulled it off.
So picture this. You're trying to tell this drone not just to, go forward, but to follow a whole series of complex steps through a busy city. For you and me, that's pretty simple. But for an AI, this task, it's called vision-language navigation, is one of the biggest headaches in robotics. It has to connect the words you say to the things it sees, plan a bunch of steps ahead, and do all of this while moving through a 3D world it's never seen before.
And just look at this actual instruction from the research. This isn't just one command, it's a whole story. It involves spotting multiple landmarks, a T-junction, a tunnel, a sidewalk, and then doing specific things in a specific order, all the way down to landing on a particular side of that sidewalk. It's a multi-layered cognitive challenge. And honestly, it's exactly the kind of thing where most AIs just completely get lost.
All right, so what makes this so ridiculously hard for a machine? Let's break down the pieces of this navigation puzzle.
Well, first off, the instructions themselves can be kind of vague, and they demand you think way, way ahead. And unlike a car that's stuck on a road, a drone has this crazy, continuous 3D freedom of movement, which just adds a massive layer of complexity. Plus, it only has its own first-person view. There's no bird's-eye map it can just look at. And in a busy city, let's be real, one building can look a whole lot like another, which makes spotting the right landmark super tricky.
So the old school approach to this problem was basically just to brute force it, use these massive monolithic AI models. But that's kind of like trying to build a skyscraper with a single giant brick. It just doesn't have the specialized coordinated structure you need for a task this complex. It totally misses the one thing that makes human navigation even possible: the incredible collaboration between all the different parts of our brain.
And that right there brings us to the big breakthrough. Instead of one giant, clunky AI, the researchers came up with a new framework that mimics the human brain by creating, get this, a team of specialized cognitive modules. So think of each member of this team as its own super-focused AI, a large language model that's been trained for one specific job. Let's meet the team.
This is FindCogNav, and its blueprint is this cognitive wheel. Now, the key insight here is that the solution isn't a single entity, it's a collection of functions that all depend on each other: perception, memory, reasoning, the whole shebang. Each piece of this wheel has a very distinct job to do.
First up on the team, you've got communication. This is the translator. Its entire job, its only job, is to take that complex human sentence we saw earlier and make sense of it, breaking it down so the rest of the team can get to work.
Next, you have perception and attention. Think of these as the team's eyes and its spotter. Perception describes what's going on right now. Currently I see a street with some cars. But then, attention zeroes in on what actually matters based on the instructions, saying, okay, I should focus on that tunnel up ahead.
Then we have this awesome duo of memory and imagination. Memory is the team's archivist, keeping this detailed log of where the drone has been and everything it's seen. But imagination, that's the strategist. It's constantly trying to predict what the world will look like after the next move, asking, okay, if I fly past that truck, what am I going to see next?
And finally, we get to the core planners: problem solving and reasoning. Problem solving is basically the project manager, breaking that huge main instruction down into smaller, bite-sized sub-goals. And reasoning is the analyst, explaining the logic behind every single choice, making sure the drone's actions are transparent and actually make sense. Okay, so we've met all the individual experts, but the real magic here isn't just who is on the team, it's how they all work together. Their collaboration follows this continuous 5-step process that feels a lot like a human chain of thought. The process kicks off by breaking down the instruction, then it perceives the world with focused attention, judges if it's completed a sub-goal, manages its memory of the journey, and finally makes a decision and takes action. But this isn't just a linear checklist, it's a dynamic loop where every single step feeds right into the next one.
So this workflow diagram shows the whole system in action. And I know it looks complicated, but the key idea is actually really simple. This is a closed loop. The output from one module becomes the input for another one, creating this constant cycle of perceiving, reasoning, and acting that turns out to be incredibly powerful and adaptive.
So here's the first handoff.
The instruction parser, our language expert, it identifies the key phrase yellow truck, but this info isn't just stored away. It's immediately sent over to the attention module, which then tells the perception module, the eyes, hey, forget everything else for a second, find a yellow truck. This is a perfect example of language directly guiding vision.
Now we get to the crucial decision point. To figure out if a subgoal like fly over the yellow truck is actually complete, the subgoal judger module acts like a panel of experts. It consults perception, what do I see right now? It checks with memory, where was that truck before? And it asks imagination, what should the world look like after I fly over it? By bringing together these three different viewpoints, it makes a really robust, context-aware decision.
And check this out. FindCogNav's memory isn't just a flat list of facts. It's hierarchical, just like ours. Step memory records the immediate tiny details. Then, subgoal memory summarizes all those little details into a meaningful event, like I successfully got to the yellow truck. And finally, instruction memory collects all those summaries. This structure is brilliant because it lets the AI remember the big picture without getting bogged down in trivial details from 10 steps ago.
And this whole process culminates in the final step. The decision-making module takes absolutely everything, the current goal, what it sees, any collision warnings, the entire memory hierarchy, and it integrates it all to pick one single best action from its list of possibilities. This is where all that thinking finally becomes movement.
Okay, this whole cognitive team approach sounds incredibly sophisticated, right? But the all-important question remains, does this brain-inspired design actually lead to a smarter drone? Does it, work?
Well, the answer came from this really fascinating study. Researchers had people watch different AIs navigate and then rate them on a simple scale. Is it a clever drone? And as you can see, FindCogNav was the clear winner. Its behavior wasn't just more successful, people actually perceived it as more human-like, more logical, and just plain more intelligent.
And it's not just about what people thought. The hard data is even more compelling. This cognitive framework more than doubled the navigation success rate compared to a standard single-module AI. I mean, in a task this difficult, an improvement that big is a monumental achievement.
So, the crucial point here, the big takeaway from all this is that the path to a more intelligent, more human-like AI might not be about building one single, incomprehensibly large brain. Instead, the secret, and maybe the next major paradigm shift in AI, lies in designing a team of specialists for language, perception, memory, and reasoning, and then orchestrating how they collaborate. It's the synergy of that team that creates the intelligence.
And this brings us to a final, pretty provocative thought. FindCogNav is a major step toward AIs that can actually follow our instructions and navigate our messy, complex world. So as these systems keep evolving, moving, and thinking more and more like we do, we really have to ask ourselves, where will they take us next?